All right, in this first section of notes, we're going to just look at a little introduction to bonding, covalent versus ionic, a lot of its definitions and some of the stuff we've seen before, a little overlap from electrons unit and some other things from other parts of units. So to distinguish between intermolecular and intramolecular, inter means between or among. So we actually will look at intermolecular forces in the last section of this unit. That has to do with like hydrogen bonding. Probably have heard that before, and then there's some other ones that you may have not heard. But we start with intra first because that means the actual bond between molecules. So inter means between or among. So think of like international. That means between different nations. Intra means within. So within the bond, within the sharing between two atoms. Intramurals, for example, means sports played within one school. So as it relates to bonding, there are forces between different substances, intermolecular forces, so such as like hydrogen bonding here. It's between different substances. And then you have intramolecular forces, which are chemical bonds. So intramolecular forces are what we start with the first. Those are the chemical bonds. And then we'll look at intermolecular forces in the last section of this unit. So these are what we're looking at. This is what we'll look at later. This is what we're looking at now. All right, chemical bonds in general, remember that elements are really not found by themselves in nature, most of them. Usually they are combined with other elements in compound form, and they form chemical bonds to become stable. So how they do it, whether it's ionic or covalent, they're still trying to achieve that same goal. A chemical bond is a force or mutual electrical attraction that holds atoms together in a substance. And bonding is on a spectrum. So we don't really have any cut and dry bonding, and I'll show you in a second the spectrum here. But it just depends on how attractive the electrons are. That's going to determine what kind of bond that it creates. So as you recall, electronegativity is the measure of the ability of an atom in a bond to attract electrons. That is very important in bonding because that's the difference is going to determine what type of bond we have. So as a reminder, less than 0.5 difference is going to be a mostly covalent bond, or sometimes we call it nonpolar. Between 0.5 and 2 difference is going to give you a polar covalent. And then an extreme difference, greater than 2, is ionic. So like this is the spectrum here. It's not always the same for every resource. You may find books or things online that will say different numbers. Again, it's just an idea, and it's all relative. So this is to give you a guideline, but keep in mind that it's not cut and dry thing. All right, compounds. Chemical bonds are formed from chemical reactions. As you recall, in chemical reactions units, maybe two elements create a compound. So, for example, two or more elements are chemically combined to make a compound, and those properties of a compound are very different from the properties of the elements that make up the compound. So think of sodium and chlorine. Sodium is super reactive. As you remember, it's an alkali metal. Chlorine is very, very deadly, actually, by itself. But if you react them and they form sodium chloride, that's just common table salt. So when a chemical reaction occurs, the atoms collide, and what happens with their valence electron determines the results of the reaction. They can either be transferred, such as an ionic bond, or shared, like a covalent. All right, a little bit of review too. Chemical formula are used to tell what elements and how many of each element are in a unit of a compound. Sodium chloride, for example, we have one sodium atom, we have one chlorine atom. Water, 2 atoms of hydrogen, 1 atom of oxygen. Ammonia, 1 atom of nitrogen, 3 atoms of hydrogen. We can also have a formula unit, that is 2 atoms of aluminum and 3 sulfate ions. which contain 1 sulfur and 4 oxygen atoms. Forming compounds. Why do they form them again? Because they want to achieve stability. They want to be stable. The octet rule, as you remember, most atoms will gain, lose, or share electrons in order to have 8 electrons in their outer shell. We have some notable exceptions like hydrogen and helium because they are in the first energy level, so they're good with 2. But to be stable, you have a full or complete outer energy level of valence electrons. And we also have some other exceptions to the octet rule that we will look at later. All right, forming compounds. Here are some Bohr diagrams of sodium and chlorine. If you recall your electron configuration, this is 1s2, 2s2, 2p6, so 8 electrons in the second energy level, and then 3s1. Now it's going to want to get rid of that electron because it's easier for sodium to get rid of 1 than to gain 7. Chlorine, on the other hand, which is a nonmetal, 1s2, 2s2, 2p6, 3s2, 3p5. So we have 7 valence electrons in its outer shell. So it really would like 1 more so that it can be stable. So sodium has 1 valence electron. It's going to lose it so that it could be, what will happen is it loses this energy level and then its electron cloud shrinks a little bit and then it will be stable. This one's going to gain 1 electron, become slightly bigger. So chlorine has 7, it wants to gain 1. And it would transfer it like that. So this is how the bond happens to form sodium chloride, which is table salt. Okay, would elements ever not benefit from forming compounds? Well, some are already stable. So the examples are noble gases, and that's because they have full outer shells, so they don't need to bond. And this would make them very non-reactive. So here's helium. We have 2 electrons in its outer shell. It's good with that. Neon, and so it's 1s2, by the way. Neon is 1s2, 2s2, 2p6. So it's good. It has 8 total in its outer shell. And argon, it's 1s2, 2s2, 2p6, 3s2, 3p6. So again, 8 electrons in its outer shell. All right. So here's our continuum or spectrum again. And we're going to look at some different properties of covalent and ionic compounds. So this table can be used to compare them. So you can write down in here as you fill in your other notes. You can go back and finish this up. All right, covalent compounds. Again, this is the result between non-metallic elements that share electrons forming a molecule. So as you remember in your intro activity, if you were looking at those cards in station 2, they had all non-metals for covalent. You are going to start with a non-metal, and that's your big clue. You're dealing with a covalent compound. And by the way, covalent also could be called molecular. That's another name for covalent. Maybe something you want to write down. And here's molecule. So molecule is a compound formed when 2 or more elements are covalently bonded. So they are synonymous, molecular, covalent. We can look at a covalent compound as one individual molecule, but not ionic compounds that way. So here are 2 examples of covalent compounds or molecules. This is water, and this is ammonia or nitrogen trihydride. Notice nitrogen, hydrogen, those are both nonmetals. So we know that in fact is a molecule or covalent compound. Here's some properties of covalent compounds. They share electrons made up of nonmetals. They can be solid, liquid, or gas. They have very low melting and boiling points, as you experienced that in the first intro activity. And another thing that they can't do is they cannot conduct electricity when dissolved in water. So by the way, these are some of the properties that you can use to fill that table out. Ionic bonds, on the other hand, transfer electrons in order to become stable. And they are typically between a metal and a nonmetal. So that's your big clue when you're looking at a formula. Is this ionic or covalent? If you have a metal that starts out the compound, it's ionic. So it's made of one kind of metal atom and one kind of nonmetal. This is called binary ionic compound, and it's referred to as a salt. Remember, salt is just a generic term. It can mean any metal nonmetal combo. So it results in the formation of ions within an ionic compound. And here is an example of a transfer. So remember that when sodium loses that electron, it becomes slightly smaller, because if it loses an electron, its cloud will become smaller, it loses that energy level. And chloride, although it doesn't appear to be that much bigger, it is slightly bigger because it's going to gain an electron. Some properties of ionic compounds: they are crystalline solids. Remember, a crystal lattice is a network of cations and anions that are mutually attracted to one another. So very organized, very condensed, nice, tight structure. They have very high melting and boiling points, and they can conduct electricity when dissolved in water. So if you think of electrolytes, those are salts that are dissolved in water. And now there's some practice, so try that.